All right, so we're going to look at kind of this random assortment of equations that aren't necessarily quadratics, right? There's no x to the second in example 1. There's no x to the second in example 2 or 3. There's something to the fourth, but we're using these methods that we've been using to solve quadratics throughout them. So the first one, hopefully a little bit of review from last chapter actually, where we need to isolate our radicals. And then we end up with a quadratic because we are squaring both sides. So careful, we're not squaring terms, right? The x isn't squaring, we're squaring the whole side. So that's why that binomial is getting squared. And of course, then this is a reminder that we are going to need to check in the end. So x to the second minus double 6x plus 36 is x. And then it became a quadratic, kind of going through that process. So at this point, because it is a quadratic, we now have a lot of methods. It may not always be factorable. Sometimes it will. And if it's not, we've got quadratic formula and we've got completing the square to work with. In this instance, it is factorable, 9 and 4. And so we've got 2 answers to check. First one works. And this one does not. So good review, but just kind of a reminder of, again, that's not, we used quadratic methods, but it wasn't because our original equation itself was a quadratic equation. So same thing is going to be true for this next one. So you'll remember whenever we have denominators, we have to address any problem spots. So x is not allowed to be 0 or 2. We got to be on guard for that at the end of our problem. But we're going to create a quadratic when we clear this fraction. So remember our method of not multiplying the numerator and denominator, because I'm not actually trying to change the denominator. I'm trying to get rid of the denominator. So we are only multiplying the numerator so that that cancels. So again, here we're multiplying kind of both sides by something. The left side just happens to have 2 terms. So this is going to leave us with 3x to the second. This is going to leave us, I'm actually just going to deal with that subtraction in just a moment, because I've still got some multiplication that is going to need to happen. And then the right side is just 6. So this is why it's quadratic-like. We're about to end up with a quadratic to solve, even though our original problem was not. So my recommendation, if you want to distribute this through the first parentheses and then multiply your binomials, you can. To me, I prefer when those coefficients are positive. So I'm going to multiply those binomials together and then deal with the subtraction. So let's see, x to the second minus x minus 2. And then now that subtraction is going to apply to all 3 parts of that trinomial. And I'm going to go ahead and subtract 6 while I'm at it. I can see it's going to be a quadratic. So we get 2x to the second plus x minus 4. So again, this is where I now have a quadratic in this other non-quadratic equation, and I have options. I can factor, I can complete the square, or I can do quadratic formula. I can tell it's not going to factor. And honestly, because of the coefficient of x to the second, I'm not super interested in completing the square. So I think the most straightforward would be to use your quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And we get 1 plus 32 is 33, which is great. That does not simplify 11 and 3 and then no pairs at all. So those would be our solutions. So again, the next one is not a quadratic because it actually has a power higher than to the second. But when I look at this, I see y to the second minus 3y minus 4. If this is half of the power here, the same basically structure is going to apply where we're thinking about a product of 4, a sum of 3, etc. The only difference is going to be that when we break down these parentheses, p to the seconds are what allow us to get p to the fourth. And then that makes sense now that our middle term is p to the second because we're going to be adding those outer and inner terms, p to the seconds plus more p to the seconds. So this is going to be minus 4 plus 1. If you want to, you can go ahead and factor this part. The next part doesn't factor anymore. But we end up with 3 ways that we can get a 0. P equaling 2, p equaling negative 2, or p to the second plus 1 equaling 0, right? We're basically just saying this parentheses could be 0, this one could be 0, or this one could be 0. And here we are just going to end up with some imaginary numbers. So square rooting both sides there, we end up with, of course, remember when we square root both sides, we also get a positive and a negative version. And we know that the square root of negative 1 is better known as I. So we have 4 solutions. That's not always true for something to the fourth, but it is possible for things to the fourth. That we have 2, negative 2, and then I, and negative I. So this one is very similar. When I see this, I am seeing y to the second minus 3y minus 4. It's just not a y. It's got an expression instead. So you will also see a process called just substitution where I'm going to say for just a moment to make my life easier, I'm going to let that expression that's being squared be equal to y. So that now I can just jump in and say, all right, well, this is y squared. This is 3y. And that's a problem that's a lot easier to work with. This actually is a quadratic, but using that substitution method is going to be a lot easier. So this is the same as we had before, I think, negative 4 and positive 1. But at some point, we don't care about y. It's not going to do me that much good to solve for y. And I could solve for y and then use that in a minute to solve for x. Or at this point, you could go ahead and resubstitute and say x minus 3 minus 4 and x minus 3, right? Just replacing that y. And then reduce now. Either way, or sorry, simplify now. Either way, you will get 7 and 2. So the last one that I want to look at with you, again, my brain is seeing that this is similar to y to the second minus 5y plus 6 equals 0. Again, right, this is half of a power, or of the original power. So like when we have typically y to the first because of a y to the second. Before you saw we had a p to the second with a p to the fourth. Same thing here. 1/3 is half of 2/3. So you could do a little substitution here if you wanted to, but I think for the most part you can recognize, all right, well, it's going to be the the negative 3 and the negative 2. Those are my numbers that make a positive 6 as a product and a negative 5 as a sum. And then either kind of 2 ways to convince yourself that this is correct. X to the 1/3 and x to the 1/3, right? When we multiply those, we actually add the exponents to get 2/3. Or looking at your middle terms, you need to have x to the 1/3 and more x to the 1/3 to get that middle term, negative 5x to the 1/3. So from here, these aren't factorable, but we know the first parentheses could be equal to 0, or the second parentheses could be equal to 0. And we create these little equations for us to solve now. So x to the 1/3 is 3. if I cube both sides, right, that's what gets this to go away. So cubing both sides, we get x equals 27. And same concept over here. Cubing both sides, we get x equals 8. So I'm going to let you pause if you would like on the next one and try this last one on your own. It's very similar to this one, and then unpause and I'll work it out for you.